Complex numbers. First, let's take a look at how the different sets of numbers are related. First, we have the complex numbers, a plus bi, where a and b are real numbers. Then I have the real numbers, which we've been working on all semester. A plus bi, where b is 0, so we don't have an I part to our numbers. The real numbers divided into rational numbers and irrational numbers. For the other complex numbers, we have imaginary numbers that are a combination of real and imaginary parts. Then we have pure imaginary numbers where a is 0 and only the imaginary part remains. Properties of the imaginary unit I. I is the square root of -1, and I squared is -1. The expression the square root of -a. If a is greater than 0, then the square root of -a is going to be equal to I square roots of a. Let's use I here to write the expression. First, we have the square root of -1 and the square root of 5. I know that the square root of -1 is I, and the square root of 5 can't be simplified, so we have simply I square roots of 5. Square root of a -100. I can break this up as the square root of -1 times the square root of 100. This gives me I times 10, which we know is 10I. The sum or difference of complex numbers. If I have two complex numbers, a plus bi and c plus di, I can add them by simply adding the real parts and the imaginary parts. The same with the difference. I can subtract the real parts and subtract the imaginary parts. Perform the indicated operation. Write the expression in standard form. Here the operation is that I'm adding. So I have an 1 plus 5 is 6, and -i plus -7i is -8i. Here I'm subtracting. So I have 2 minus 1 is 1, and a -7i minus 2i is -9i. Here my operation is multiplication. These parentheses are set right next to each other. So when I'm going to multiply these, I need to FOIL. I'll go 3 times -1 is -3. 3 times 5i is 15i. 2i times -1 is -2i. And 2i times 5i is a positive 10i squared. Now we have like terms that we can put together, and I also have an I squared. So that gives me a -3, a positive 13i, and a positive 10 times -1, because I know that I squared is -1. This gives me a -3 plus 13i minus 10, which is in a plus bi form, -13 plus 13i. Again, I'm multiplying, so let's FOIL this. 1 times -6 is -6. 1 times -i, -i. 2i times -6, -12i. 2i times -i, -2i squared. So this gives me a negative 6, a negative 13i, and a negative 2 times negative 1. So negative 6 minus 13i plus 2 gives me an a plus bi form, negative 4 minus 13i. Again, I'm multiplying here, simply a monomial by a monomial. So I have negative 4 times 5 is negative 20, and I times I is I squared. So this is negative 20 times negative 1, which gives me a positive 20. Here I'm squaring a binomial, so you can write this out as 2 plus I times 2 plus I, or you can remember the a plus b squared is a squared plus 2ab plus b squared formula. Here let's go ahead and FOIL. 2 times 2 is 4. 2 times I is 2i. I times 2 is 2i. I times I is I squared. So I have 4 plus 4i minus 1. And in a plus bi form, I have 3 plus 4i. If I had done the formula a squared plus 2ab plus b squared, I would simply take this binomial and put it into the formula. I square the first term, I square the last term, and I multiply 2 times the first times the second, so 2 times 2 times I, and that gives me 4 plus 4i plus a negative 1, which is going to be 3 plus 4i. It really is your preference whether you want to go ahead and FOIL or use the formula. That covers this section. Go ahead and try your homework and be sure to let me know if you have questions.